So I cannot be in the live session today, so I have pre-recorded this so that you can watch it as if we were in class. So this is topic 3. We took our test. It's today for me since I'm recording this ahead, but for you guys it was yesterday for topic 2. And so we are now starting topic 3, section 1, and this is going to be the first day. So topic 3, section 1 is on functions and relations. And so we're going to start by just doing some definitions. So feel free to pause the video as much as you need. So a definition of a relation is a set of ordered pairs relating to variables. And so here's an example. So we have two variables, and so a relation is just a set of ordered pairs relating to variables. So here's what this equation here would look like on a graph. And then a function is a relation in which every input has one unique output. So a relation in which every input has one unique output. So here is a function. So f of x equals 2x plus 1. So here's the output and here's the input. So x is our input. And so anytime we put in one number here, we're going to get one output. If we plug in 2 here, we shouldn't get two different answers. We should only get one. Domain is the set of all inputs. So all your x values, and we write it with x. And then this little e here is saying the element. So x is the element, and then you write your lowest number and your biggest number. And then the range is the set of all outputs, so all your possible y values, and you write it similar. You just change from x to y. And again, you write is the element, and then the lowest output you have and the greatest output you have. So go ahead and pause if you need to write these down. And again, these are some definitions that we're going to be using for this topic. One thing also to note is that there is a rule when you're writing these interval notations, is what this is called. And so you're going to have what's called a hard bracket. So it's more like a little half square or half rectangle. And that's when you include the number. So again, this is when you include the number. And then you'll have parentheses when it's not included. So our first example, Sarah earns $10 per hour worked at a retail store in addition to her base salary of $50 per day. So first we're going to write the function, and we know that she makes $10 per hour plus this $50. So we're going to have f of x, that's our function notation, equals the $10 per hour plus the $50 that she gets each day. What is the domain? So remember, that's all the inputs, so that would be hours in one day. So we would write this as x is an element, and then she can work 0 hours, so we're going to have a hard bracket, which is, remember that, like half rectangle or half square. 0 to, technically she could work 24 hours in a day. Ideally, that's not realistic. However, there is 24 hours in a day, so we could go from 0 to 24. And both of these have hard brackets because they are included. The range is the output, so if she works 0 hours, technically she's still going to get $50 because that's her base salary. So the range is the amount of money she can make in one day. So we have that she can make she can work 0 hours, which means she's going to get $50, which in my head I'm thinking, oh, that's kind of nice to work 0 hours and make $50, right? So $50. Or she can work 24, so we would do the 10 times 24 plus 50, we get 290. So this is the possible range. This is the possible domain. If we were live, I had a poll question for you. Obviously, we're not going to be live today. So how much money will Sarah earn for 5 hours of work? So if I were in class right now, you would be we would be pausing and you would be solving this on your own. So go ahead and pause the video, try this, and then check your answer. Okay, so then if you plugged 5 hours in, that's saying that x equals 5. So we would do f of 5 equals, and then 10 times 5 plus 50. So 10 times 5 is 50. And then 50 plus 50 is 100. So it would have been A. What if she works 6 hours one day and 3 hours the next? We would do f of 6, and then we would add our f of 3. So you have to do it twice. So f of 6, we're going to plug in, and we do 10 times 6 plus 50. Again, we're using this function up here. And then f of 3, so we're going to do 10 times 3 plus 50. So this is 60 plus 50, so we get 110 plus the 80. So if Sarah works 6 hours one day and then 3 the next, she's going to make $190. What if Sarah made $110? How much did she, or how many hours did she work? So she made $110. How many hours did she work? Well, this 110 is our f of x. It's our output. So we're going to write our function with 110 in this spot rather than plugging in for x, because this isn't our input. This is our output. So we're going to put 110 here. And then we're going to solve. So we're going to subtract 50 on both sides. So now we have 60 equals 10x. Divide by 10 on both sides. So Sarah worked 6 hours to make $110. Again, if you have any questions, you can email me. Feel free to pause the video as much as you need. We're going to go to example 2 now. So to determine if the following sets of ordered pairs represent a function. So remember in the very beginning that we said a function has to have one output for every input. So basically every x value right here or right here needs to have one output. So number 1, if I'm looking at it, 0, 1, 5, 6. Right now I'm just looking at my x values. There's no repeating x values, so each input has a unique output, which means this is a function. Then number 2, looking at the x values again, I have 2, 3, 4, and 2. So 2 is repetitive. It's there twice. And it says if I plug in 2 here, I get 4. But if I plug in 2 here, I get 6. So that input of 2 has 2 different outputs, so it's not a unique one, so it's not a function. What I would recommend at this point is pausing the video and trying the next 3. Again, you're looking at the x values and making sure that they each have one output. So they each only have one y value. So looking at number 3, I have 0, 1, 2, 3, 4. So no repeating x values, so that is a function. Number 4, 2, 6, 7, 8, 2. 2 is 3, 2 is 7. 2 can't equal 2 different outputs, so that is not a function. And this one here, no repeating, so that is a function. Let's look at example 3. Determine if the following graphs represent a function. So again, we are looking for every input having one output. When we're looking at a graph, we have what's called a vertical line test that we can use to see if it's a function or not, and that is a visual representation to determine if a relation has one output for every input. So it's in the name, vertical line. So we're going to take a vertical line and just kind of put it on our graph. What I also call it is the pencil line test. So if we were in person, I would be putting a pencil down and then checking to make sure that my pencil only touches the graph once. So here's my pencil or my vertical line, and I'm looking where my graph touches it, and it only touches it once. And I could move this red line over left and right, and it would still only touch once right here. So it is a function. Again, I would highly recommend that you pause and try the next two. So here's a vertical line again, and it touches here and here, so it is not a function. In the next one, I draw my vertical line and it touches once, so it is a function. Okay, and one more example, example 4. So we're going to be writing some more interval notation, which we already kind of talked about. So we're going to be stating the domain and range of these. So interval notation is just putting all there. So we talked about it at the beginning. So interval notation is when we have that brackets, the hard and soft brackets. Again, hard brackets mean it includes it, so you're going to see a solid dot. And parentheses is when it excludes it. It does not include it, so you would see an open dot. So domain is all our x values, so we're going to be looking at the x values. So again, we said domain, we start with x as an element, and then we look from where the x starts, which is here, and ends here. So it's an open circle, so we're going to have a parenthesis, and then -4, and then we go all the way, and we look, and it goes on forever. So see the arrow? So it goes on forever. So it actually goes to infinity. And infinities always have a parenthesis. And then range is the same idea. You're just looking at the up and down. So we're at y as an element. And again, we're looking from here, where it starts, the lowest bound, and then the highest. So it goes from -1, again, open circle, so parenthesis, to infinity. Now, if you feel comfortable, I would pause and try the next two. If you don't, I'm going to do the next one, and then you could pause and do the last one. So again, domain is our x value, so where it starts here and where it ends here. So from -4 to 3. -4 is included, and then 3 is not included. It's an open circle, so it's going to be a parenthesis. So again, x is an element, and then hard bracket, soft bracket, included, open circle, not included. And then the range, from here to here, open circle, so they're both going to be parentheses. And there's that one. Again, pause the video, try this one, check your answer. Okay, so domain starts at -3 with an open circle, goes till 4 with a close. So x is an element, parenthesis, -3, and then all the way to 4, hard bracket. The range starts here and goes to here. Open, soft, closed, hard. Parenthesis, half square rectangle. So y is an element of 0 to 8. Okay, that's it for the recorded video. There is an exit question that you are going to be completing on Canvas, so please make sure to go to Canvas and take this graded graded quiz for the exit question. And I hope this made sense. Again, email me with any questions and I am happy to help. Have a great day. See you all on Thursday.